Section 12.3b is about dimensional analysis. This is something that you can use in science or whenever working with real-world problems that have units included. When you multiply fractions that involve units of measure, you can divide by the units the same way you divide by the variables. Let's take a look at what that looks like. Here you see an example using dimensional analysis. Not only are we multiplying these numbers together, but we're including the units with the numbers. Now what does this do for me? This allows me to cancel units that are on the top and on the bottom. So here I'm going to cancel seconds and seconds. I'm going to cancel minute and minute. And I'm going to cancel feet over here on the left with feet down here. And what I end up with is 24 times 60 times 60. We don't have to multiply by 1. But then we have miles on the top. And here we have 1 times 1 times 1 times 5,280 with hours on the bottom. So if I take these numbers and plug them into a calculator and actually get a decimal answer, I'm going to get 16.36, and in this case it's going to be miles per hour. So this is how you can take a set of numbers and convert them into another set of numbers, another set of units, by using this cross-canceling idea with the units. Here's an example that we're going to use. In this one, I want to find out how to convert a 100-meter sprint that took 9.87 seconds. So in this case, I want to convert meters per second, and I want to change that into the speed of kilometers per hour. So I want this to be kilometers per hour. And so I'm going to use dimensional analysis to go from minutes per second to kilometers per hour. So we'll start with 100 meters over 9.87 seconds. Now the trick is to multiply by a fraction that will cancel these units. So I want to put on the bottom here, I want to put meters, but I want to create kilometers. So I want kilometers on the top and meters on the bottom. Well, how many meters are in a kilometer? There are 1,000 meters in 1 kilometer. So that's going to allow me to cancel meters and give me an answer that's in kilometers. The other thing I want to change is I want to change seconds into hours. So I got to put seconds on the top, and I'm not going to go seconds into hours. I'm going to go seconds first into minutes. And there are 60 seconds in 1 minute. And why did I put seconds on the top? Because seconds will cancel with the seconds that are on the top, because you always want to put the unit on the opposite side, top or bottom, so it will cancel. And now I'm going to have 60 minutes in 1 hour, again putting the minutes on top so that those will cancel with these minutes. And let's see what I have now. I have 100 times 1, which I'm not going to write, times 60 times 60, and the bottom I have 9.87 times 1,000, and then I have kilometers per hour. So my answer here is going to be in kilometers per hour, which is what I wanted. So now take a calculator and find this number. I get 36.47 kilometers per hour. So that's how fast a 100-meter sprint that took 9.87 seconds is if I sprinted in kilometers per hour. Here's our last example for dimensional analysis. We're told the moon is about 240,000 miles from the Earth. There's really no comparison there, so we're just going to start with the given fact of 240,000 miles. But we want to convert that into 100 miles per minute. We want to know how many days it's going to take. So we want to end up having a unit that's days, which means we don't want the miles unit to even be here. So I'm going to make my next fraction 100 miles, because I know that that's going to cancel off with the miles over here. And then I'm going to say 1 minute. And then what I can do is I can convert that 1 minute into a certain number of days. So we're going to do minutes on the bottom here, so it will cancel, and we're going to do hours. So 1 hour is 60 minutes, and then I want the hours to cancel, so 24 hours are 1 day, and then I'll end up with just having a day. So miles will cancel, minutes will cancel, and hours will cancel. We'll end up having just a day unit, and the numbers we'll use is 240,000 divided by 1 times 100 times 60 times 24. And that's going to be in days. So use a calculator and figure that number out. And I get 1.6 days. Actually, we'll round that to 1.7 days it would take.